So we did the ping pong ball launcher for our project. Unfortunately, Porter was unable to be here for this video, but we're gonna continue without him.
These are our just introductions with our majors of everyone that was on our team. This is our project description of the ping pong ball launcher, like we said. The purpose was to design a constraint a launcher to hurl a ping pong ball 10 feet laterally. The dimensions for the target will be provided to you in a separate document, which turned out to be 6x6, laying on the ground in a circle. So we realized that the purpose of this was to hit the target 3 times in a row.
Design and improvements. So there were a total of 3 kind of brainstorms or ideas that we had implemented on paper. So designing the launcher itself was an interesting task. We drew up, like I said, 3 designs. We had thought 2 of them had been good ideas. 2 out of the 3 had been good ideas, but they turned out to have inconsistencies, and there was a significant room of error between them. So pretty much this right here is the first one that we evaluated. It's a CO2 powered cannon. So in the back, the cartridge of CO2 can go in, and then it's able to be muzzled in by a kind of like a pipe, if you'd say. And then the second one is a catapult type device. Yeah.
Alright, so for brainstorming, as a group, we decided on one final design concept, and we concluded that this design was a more practical and simpler approach to meet the project guidelines, and as well to improve certain constraints we would encounter as the project further progressed. This approach allowed the team to obtain a level of consistency, which also introduced a higher level of thinking when it came to deciding what we wanted the materials to be. In this picture, it might be kind of hard to see, but we label a lot of materials. For example, like we have the PVC on top for our barrel. We have wood down here for our base, as well as for our increment blocks that would adjust the height of our launcher. We had an industrial strength rubber band at the back that we used to propel our wooden dowel that you can see right here that we labeled. And yeah, that's about it.
These are just some more of our sketches of our final design. This one kind of shows just the side view of it. Some of our design process that went into just the catapult itself, the design, why it works, what we've done so far to help us stay on track. Again, this is like a list of our materials, a top view, another side view, of just what we envisioned it looking like. So yeah.
So the overall performance, through the midway stage of development for the launcher, there were apparent strengths and weaknesses the group had to take into account of as we started designing our first idea. So one of the main weaknesses that we all noticed as a group was for using a CO2 cartridge for our original idea, there wasn't going to be any way to gauge the pressure or the PSI levels. And this weakness introduced the undesirable outcome, which left us with no other choice than to scrap that initial idea. The strength of this was it provided a broader overview for the ability to reduce the percent of error, essentially allowing us to develop the idea of using an industrial strength rubber band as a new launching mechanism. So it pretty much worked out in our favor. We still got the desired outcome, and we were able to meet the expectations of the project's guidelines.
Alright, so these are some of our design improvements. On top, you can see here, this was part of our new design, where we decided to use a big metal clamp to clamp down our barrel so that it would stay in place on our wooden block here. And then these 2 little like metal screws or hooks were what we used to secure down our industrial strength rubber band, and that seemed to work out really good for us, so that's what we went with. So yeah, our team had made significant progress through week 1 to week 5, but at week 6 there was a few changes that had to be made based on the progress of our prototype launcher. So like I was saying, the PVC had been placed on the upper level of the launcher, which is right here. Using electrical tape, we figured it was strong enough to keep the barrel centered, but we were actually wrong, which is when the metal clamp came in place, and we needed to properly secure the industrial rubber band on the launcher in order for the ball to project at the proper angle and height.
Testing. So the first form of testing that we did as a team was we needed to figure out how far we needed to pull the wooden skewer back. And so we began to mark down, as you can see in the picture, different release points of the skewer, just depending on how far the ball would go at that range.
The second form of testing that we did was gauging the height levels. As you can see, there's 4 levels, and pretty much each one offers a different launch for the launcher itself. So through trial and error, the team successfully obtained the proper results we needed in order to meet the goal of hitting the target 3 consecutive times.
Alright, so some more testing that we had. We tested a variety of ping pong balls. These were the final 2 that we went with in the picture. We actually decided to use the Texas Tech ball because that's what worked better for us, because this one had a couple cracks in it, and that would very drastically change our launch variable, like it would go left and right a lot, and so that's why we decided to use this one, because it was a lot better ball. Yeah, so we were able to draw that not every ping pong ball holds the same weight, and it would significantly impact the distance and the height that the ping pong ball needed to meet. Concluding our testings, we were able to comprehend that a ping pong ball weighing more than 2.964 grams was too heavy to project and obtain consistency and accurate launch results.
Some obstacles that we faced as a team. Throughout the 8 weeks as we constructed the project, there were challenges the team was faced with. One of them was the challenge of determining the constraints and dimensions of our wooden base for our launcher. We were able to determine that the base needed to be twice the size of our PVC to give us max stability, as we struggled with stability in the very beginning.
So another obstacle we faced was whenever we had the wooden dowel inserted into our actual contraption, we weren't able to get the ping pong ball launching correctly just because we were using the dowel itself as the launching mechanism. There needed to be an end piece which would kind of project the ball out. But we were able to create a device that was sturdy enough and pretty much held consistency throughout the trials that we did to project the ball out.
So continuing on with this, like he was saying, without the little piece on the end of it, the ping pong ball would constantly get stuck in between the side of the barrel and the wooden dowel, and that was a very big problem for us. And so, like Jaden was saying, we stuck a little bottle cap with some plastic around it, and that was able to stay on the dowel good enough for us to where it would launch the ball pretty consistently every time. Another obstacle with that was it kept falling off a few times, even though we did tape it and super glue it, and it got really annoying. But it finally just kind of stayed on, I guess, due to luck.
Do you want to show them?
Yeah.
I forgot we had that.
I don't know if you can see it though in the video.
You can probably pull it out. Here, I'll take this. Sorry, fancy metal clamp.
So yeah, like we were saying, this is what we decided for our final product. So like I was saying, we have the bottle cap right here, and then this little plastic piece on the end, and that was able to project our ball consistently every time. And so that's why we decided to go with that. But without this piece on the end, the ball would get stuck between this wooden dowel and our barrel, and the ball would not launch because of that. And so that's why we decided to go with this little end piece.
Lesson learned. Every team member was fully invested in order to meet the deadlines for weekly progress videos, overall building of the ping pong ball launcher. We gained a significant amount of knowledge regarding teamwork, work ethic, communication, and time management.
So in some cases, there are often times where an individual is placed in a group where he or she does not prove to be an asset or much more impact the overall presentation of the project. But not in our case. You know, every team member helped. They pulled their own weight, and we kind of all worked together to, you know, achieve the goal of completing this project in a timely manner, and everything worked out at the end. So yeah, any questions?
Is that it?
Yeah.
Yeah, that's
Yeah.
it.
Cool. Thank you.